years, I'm like blown away. And I guess I was going to talk a little bit about what a sort of scary time this is with Ukraine and the world getting topsy-turvy again. And I think actually that Passive House Accelerator came out of the hardest time is really an optimistic thing, right? We took a really dark thing and took the lemons that we got and made lemonade and created this amazing community here of lots of people learning and being inspired by each other. I think that's really cool. And honestly, even the scary, terrible things that are happening in the world right now, there are little bits of sunshine coming through, right? Like, it is scary how fuel prices have changed so quick. And it reminds me of like way back in the energy crisis when every other day you could go to the gas station, right? It's a different way of thinking. But I do think it's made something that is, especially in Europe, like Germany, really, it wasn't very obvious to them how reliant they were on natural gas. And now it's become a security issue, right? It's not just a cost thing. If costs come down again, people will think about it differently. And honestly, here, gas prices were really high for a while. They're coming down again, but I've never had so many people ask me about my electric vehicle. So there are some positive things. We can try and find those things and maximize those things. And so tonight, I just want to cheer on Passive House Accelerator for really taking a dark, dark time and making it into an amazing, amazing thing. So cheers to Passive House Accelerator and 2 years.
Cheers.
Cheers.
We're here.
Great. Thank you, Bev.
Cheers.
Cheers, everyone. All right, we're going to go into breakout rooms for 5 or 6 minutes. This is a rapid, quick introduction of your small group. So make sure you get around to each person. And let me set this up. Bernard, I think everybody is back. So let's get moving. Bev, I'm going to hand it off to you.
Sure. Thanks, Zach. So we have a real treat tonight. Like, I'm super excited. I got to say, the rehearsal for this was so much fun. There were 4 women and Zach, and you don't get that kind of number very often. So it was really exciting. So I'd like to introduce our speakers tonight. Sharon Libby Everly is the quality director at Walsh Construction. She joined them in 2013 and has been serving as their quality manager on many projects in Washington and Oregon regions. And I can tell you, even from the rehearsal, that you can tell that she's a really super positive person. And she brings that to all the work she does and has really been focused on proactively addressing needs of teams in construction as they pursue the highest level of quality in their projects. And then we have Greta Cheltve. I'm probably butchered that, sorry. She is the building support coordinator at Evergreen Certified. And Greta really found green building, I think, when she was doing research on rebuilding in New Orleans after Katrina. And she went on to get a BA at the architecture at University of Washington. And she wanted to do some hands-on work. So she spent 2 years doing construction work with Habitat for Humanity in Seattle King County as an AmeriCorps volunteer. And it was her former Habitat coworker, Sybil, who now is her fellow Evergreen Certified Senior Verifier, who convinced her that building science and energy raters really suited her interest in a balance between on-site work and in-office work. And so I'm really excited. This project is exemplary in so many ways and such a good thing to follow Women in Construction Week. So I'll hand it over to the team.
All right, I'll go ahead and share my screen. I'm sorry for a little clunkiness to start here. Okay, I don't know why this is, okay, there we go. All right, let me move you guys around a little bit. Hi, I'm Sharon Libby Irely, and we'll be introducing to you to our big passive project here in Seattle, Washington. Our client, DESC, is an affordable housing provider here in Seattle, and Hobson Place, named in memory for their former executive director, provides 177 units for those in critical need of housing. The south phase of the project is our focus today and is almost 93,000 square feet. 7 stories tall with a mixed-use program of a medical clinic space below the residential floors. It's located in the heart of Seattle and not far from downtown, so a very urban setting. And this is a little bit about us at Walsh. I started at Walsh in 2013 as a quality manager, and after a short decade in architecture, I am now Walsh's quality director with a team of 4 quality managers and 2 enclosure superintendents across our Washington and Oregon offices. Our quality program started well before my time, establishing a collaborative approach to enclosure design, documentation, and execution in the field. This process is implemented on all of our projects, not just the passive house ones. And I'm proud to say with this collaborative approach and careful attention to detail, we're seeing many of our projects edge closer and closer or even achieve passive house performance on several fronts. And Greta, do you want to introduce yourself?
Yeah, so to clarify, that crazy letters after my name is pronounced Cheltbait. It rhymes with shark bait, if that helps you remember it. So I'm Greta Cheltbait. I'm a senior project verifier at Evergreen Certified. As Beverly mentioned, I've been with them for about 5 years and had a background in architecture and then at Habitat for Humanity. Evergreen Certified came about in the Great Recession as a way to actually help market our builders' projects so that they could sell them when there really wasn't much to sell. We verified some of the first passive house projects in Seattle and Washington State. And we manage actually over 300 builders currently of projects with varying size and certification types. We provide on-site quality assurance inspections, as well as diagnostics testing to meet both code and certification program requirements, and are verifiers and raters for a multitude of certification programs.
All right, thanks, Greta. So Greta and I are just part of a larger team, and that we are happy to note had a majority of female leads for the project. Also, the core team of Walsh, DESC, and Runberg have more than a decade of experience working together, which was definitely a benefit when approaching an ambitious project such as Hobson Place. There were many aspects inherent to both commercial, larger scale construction in general and Hobson Place specifically that really challenged some passive house measures. And we tried to summarize and group those into as few F words as possible: function, funding, and form. And now keep in mind that not all F words are negative. These are really what made the project possible and what it is today. The function, starting with the program, presented some unique challenges to passive house. The building houses a behavioral health medical clinic at floors 1 through 3 and 92 apartments on floors 4 through 7. Each use required different needs for access, circulation, safety, utility demands, and other stuff. We will get into the whys of this in a couple of slides, but passive house was applied to only the residential floors, levels 4 through 7. And what this decision created were many overlapping and interlacing volumes affecting the passive house boundaries, mainly the stair and elevator cores, as well as mechanical shafts going to the garage and to the roof. Hobson Place South is connected to the north face building that you can see on the right-hand side of the slide, which we completed for DESC in the prior year. And that connection had implications to the passive house air barrier, as well as resident needs for circulation and access to all the different services. And there were additional performance goals in addition to passive house, including operational goals that are typical for all DESC projects. The residential population here is at home for most of the day, and therefore the apartments need to be durable and well ventilated. And while these goals sound perfectly aligned with passive house, the operating and maintenance of the building and mechanical equipment is typically done in-house, so equipment selection was very carefully approached. Affordable housing also has limited resources for ongoing maintenance, so the systems as well as the materials need to be durable. Hobson Place South is a demonstration project for a local utility, Seattle City Light, and an advocacy group called Exemplar Buildings Programs. This pushed the project to achieve an EUI of 20 and to be all electric. The biggest changes in reaching those goals were the use of hot water heat pumps and for domestic hot water rather than gas boilers, and the 40 kilowatt PV array on the roof. Which is a great introduction to our second F, funding. 2 funding sources became available for the project specific to affordable housing that allowed DESC to pursue a higher performance path. The first was a state program for ultra high energy efficiency buildings, in which FIAS is a path to compliance. The second was Seattle City Light demonstration and exemplary buildings program that I mentioned before. The design for Hobson Place was largely completed before FIAS certification and the SCL program was committed to, so measures such as increased wall and window performance, hot water heat pumps, balanced ventilation with improved mechanical equipment were added after the bulk of design was determined and those costs were tracked. The incentive funding covered all passive house and SEL adds plus some soft costs and inherent performance goals. It's important to note that while we have seen great cost efficiencies realized when passive house is committed to before and during the design, this building being in Seattle with some of the most stringent energy codes in the country and serving the needs of affordable housing, think durability, low cost maintenance, operations, healthy air, and materials, really raises that baseline. And we'll talk more about challenges of applying passive house to this project, but note that we weren't starting with a poor performing building. This graphic is a great one to quickly understand what it takes to achieve the goals established by Hobson Place team. Provided by a local housing advocacy group, HTC, a couple of years ago, this illustrated the main pushes in getting to and the EUI of 20 really need to be with the domestic hot water supply and space heat needs, which really translates into the building enclosure for our climate. We like to think of Seattle as a special place, but it really is for the latest energy codes. And our current codes, which is one cycle beyond this building, now require many of those measures, such as ducted balanced ventilation with energy recovery, a better enclosure, domestic hot water heat pumps. And essentially, when you look at the difference between the code minimum and the passive house, that gap is narrowing and the cost premium really will be narrowing as well. Our third F word is form. A significant portion of the building was not included in the passive house boundary. So that would be the parking garage, the clinic spaces, and then phase one. And all of those non-passive house spaces have connections to the passive house enclosure. And in the case of the mechanical shafts serving the different uses really cut through those spaces. Included in the passive house enclosure are the 92 residential apartments in the 4 stories of wood framing over a 4th floor concrete slab. Now the form and plan isn't simple either, and one could say, well, why not make this a little easier and make it more of a box? An affordable housing unit layout is very important. The design needed to accommodate as many units as possible, along with the service spaces needed on each floor, and a simple box doesn't typically allow for that. And here the H-shaped floor plan was suited the unit layout and the owner's needs, and then again, that was determined before passive house was decided to be applied to this project. And here's another look at those stair and mechanical shafts in the building. And so these are the included passive house enclosure, or spaces that were included in the passive house enclosure as they serve the residential spaces. So you can see their shape varies a bit as they go through those non-passive house floors at the garage and the clinic spaces. So each of those boundary walls had to be detailed for air tightness and thermal boundaries in cases where they leave the heated portions of the building. So Orchards at Aranco was our first, for Walsh anyways, our first passive house project. The building is 3 stories of passive house residential spaces over a slab on grade. And as you can see here, is pretty open at the exterior walls, allowing for access via man lifts throughout the duration of construction. The exterior wall air barrier is sealed plywood sheathing with tape seams, and mechanically attached WRB was applied on top as well. We found that our past passive house experience served us well in many regards, but it was also very different than Hobson Place. So as mentioned before, the passive house spaces at Hobson Place are the upper 4 floors. And access to the elevations was via scaffolding and a crane, as there's limited perimeter space. You can see the orange flags that mark out the power lines to the east along here. And so that was our do not cross line. And then on the west, there's a very small alley that we had to put a job trailer in. And the north side is connected to another building. And so the south side was really the only one that was open, but we could also not block the street. Because the building was fully scaffolded, the sequence for install the exterior wall materials followed the scaffolding 1 elevation at a time around the building. And this made it a little challenging to plan for a pre-test of the air barrier prior to cover. So we decided to use a self-adhered membrane for the air barrier and WRB to help with that timing and sequence. There were a couple of curveballs with the plan sequencing that I'll get into a little bit later. So we recognized the differences and applied our experience where things seemed applicable and adjusted based on that experience where the design and site conditions diverged from what we had done in the past. And as I get into more of the details, I only have time to share a few, I'll let you know what was planned, where things went a little differently, and what we learned. And how did we accomplish it? This big of a passive house project, a large mixed use building. I'll take you through some of the key project details, how we adjusted for the larger scale construction, some of the curveballs, teamwork required, and lessons learned. So starting at the roof, we had an assembly with R50 insulation and the vapor barrier serving as the air control layer. And we needed to reduce penetrations in that air control layer, so we were able to get the ductwork for the passive house areas of the building within the enclosure. And here you can see a great comparison of the north and south phases. And you can see the ductwork on the north phase that was all exterior, and then on the south phase, there's hardly any ductwork at all. So these are our big ERVs and not much ductwork. I think there's a little bit up here, but that was actually for the clinic spaces. We started our air control at the roof perimeter, accomplishing that tricky roof to wall connection with first pre-stripped vapor barrier that laps over the wall air barrier, then the platform or parapets or platform framed on top. And this is fairly typical detail for us that we try to make happen on every project. Then the rest of our roof vapor barrier and air control was hot mopped and tied into that peel and stick at the perimeters. All curbs were then framed over just like the parapets, so we can maintain the continuity of the air control layer. We did have one section of the parapet that couldn't be platformed, framed for structural regions that we had to adjust for. So here you can see the two different structural details and then how we adjusted the line of air control in the field to go up and over this parapet and still connect back down to the roof. And this took teamwork from our design team and installers in the field to ensure that all transitions were addressed. Then any penetrations in the roof vapor barrier and air barrier were sealed and insulated. And you can see here the mechanical duct stub outs that were in place well before any mechanical equipment was on site, so we could detail them with the other air barrier materials were still accessible. And this is a great example of how the typical sequence had to be adjusted to ensure detailing could be accomplished. And those stub outs were also important to have in place early for interior detailing. These images show the ERV trunk lines that were brought inside the passive house enclosure, fitted into the ceiling space of the 7th floor corridor. That was done by using car decking to skinny up the framing and 1 hour rated ceiling space for the ducting to be housed. And then our design team worked with the jurisdiction to allow 4-inch ducting into the units, which eliminated the requirement for fire smoke dampers that would have added significant cost. So that was a win on all fronts, really. The air barrier at the north wall was actually installed with the north phase building. There was a lot of planning for this wall since it was to be in place months before the south phase was even out of the ground. We used a silicone liquid applied air barrier that could be left exposed to the elements in UV. Then tie-ins at the slab, shear wall, and other transitions were carefully planned ahead of time in a series of diagrams like this one. We worked with the design team on several options for detailing at each of the conditions, so we'd have those options as we moved into south phase construction, and that was before it was even fully designed. And here is what some of those transitions look like. Silicone transition strips were used to connect the concrete of the south phase to the silicone air barrier at the phase line wall. There were also wall-to-wall connections like this one that had siding held back a few inches in the north phase so that we could tie in once the south phase building was in place. And most of our planning worked out for these details. I think we only had one small section where we actually had to remove some siding to access the air barrier and reinstall it. And the south phase building is 1 story taller than the north, so there was a roof to wall connection too, and you can see our installer standing on the parapet top of the north building, connecting the air barrier into the roofing materials, then again, the roofing vapor barrier of the south phase. The exterior walls were 2x8 wood frame to allow for R30 blown in bat insulation. This wall assembly is kind of a sweet spot for thermal control in the Pacific Northwest, allowing for an increased R value without going to exterior insulation, but still avoiding that condensation risk within the wall cavity. Blown in bats should be installed to the manufacturer's stated density, but how do you check that? One manufacturer makes a density gauge just for that purpose. However, it comes at a cost and a weight. It'll need to be shipped up from California. And by the way, we're sure to use the manufacturer's scrim because that could affect the density reading on the gauge. So, well, due to supply chain issues, the insulation manufacturer's scrim was actually not available to us. So another one was used. And this didn't come to us as a surprise, though. We knew of supply chain issues that they've been pretty common over the last 2 years. So we had actually had the insulator submit on a few manufacturers' products because no one knew what actually was going to be available when it came time to do the building. So we measured the density of the blown-in bats the old school way, and this was something we actually did at the Orchards project as well. We cut out a cubic foot and weighed it. We did this check in a few places on each floor before we had Greta do her checks, and that way our insulator could make the adjustments as they installed the material versus having to come back and slow down any subsequent trades. One curveball that came our way was that we had a few areas on the 7th floor in the roof penthouse that had 2x6 framing. R30 blown in wouldn't fit. So once we identified, which was pretty early, this issue, our design team and Passive House consultant were able to check the model and approve the R23 blown in bat for those walls. But however, once the crane was removed, there was no way to get that blowing machine back up to the roof. So a little bit of a catch-22 there. The crane was utilized to hoist that machine to the roof, which I hear is about 2 to 3 times my size, and no one wanted to lug it back up the stairs. So then the roof and the walls were insulated moving down through the building, a little bit easier to move that machine around. And then the crane was actually removed. It was located in the stairwell, and the crane was removed in order for the penthouse framing to be completed. And by then, that blowing machine was actually not on those upper floors at all anymore. So sequencing is a huge part of every project, but for larger scale projects, it's crucial as sometimes not an option to hold off another trade or bring equipment back or close off access to the areas of the building. But this stairwell was going to be needed, or was going to need to be insulated with bats and by hand. Working with our insulator, we found that 2 layers of R15 compact bats would fit in a 2x6 wall. However, the compression of those bats reduced the insulative value down to R22. But since the blown in was only getting us to R23, R24, Passive House team was okay with this approach. And it was in a very limited area, so it didn't have much effect on our model. It was a great example of how working together as a team provided a feasible solution. And now the install, though, was a whole nother ballgame. You all know what a stairwell looks like, so this picture isn't a much surprise. And that high wall over the stairs that go down is very difficult to reach. And that led to a non-grade 1 install. So you can see the insulation layers pancaking in this area here where it was hard to reach. And also we have structural blocking taking out large sections of the installation in its entirety. So in larger scale construction, the 2 things that override performance goals are always safety and structure. And this is a perfect example of both of those things. This stairwell is serving as our second point of egress for the building, so blocking it off was not an option. Uneven ladders that are not permitted by our safety standards, and scaffolding would have been an extra expense. So the insulators were able to correct this with their proprietary extension pole tool, but it wasn't simple with the limits on access. And like safety, structural blocking is not optional either, so that obviously had to remain in place. It took teamwork from the Passive House design team to our suppliers and installers in the field to get these walls insulated with the best product and installation as possible. Now, our windows are all triple glazed with values of 0.18 or better. The interior perimeter air seal was made continuous at all 4 sides, which is typical on all of our projects, and each one QC'd by our field enclosure specialist, or what we call our skin doctor. If you notice the reddish hue to the framing, that's fire treated lumber required for type 3A, which is what we had here for the framed portions of the building. We had a slight adhesion issue, but we're able to work with the air barrier manufacturer to find a couple solutions to ensure everything was well adhered. When we started planning and budgeting for the exterior wall air barrier, we looked to our experience and tested results. And these were our top 5 projects for air tightness. Not all of these are certified Passive House. 2 of them are, but we've accomplished other buildings that are within that range. So these were great experience. And as you can see, 3 of 5 used sealed sheathing for the air barrier. We actually decided against that approach at Hobson Place since we did not have the open ground access of those previous projects. We also had an install sequence that was per elevation rather than per floor. So we need to be able to tighten up the timing between the installation of the air barrier, WRB, and windows with 1 trip around the building. That and a few other reasons led us to the decision of a fully adhered membrane for the air barrier. And now this picture is what we had in our minds during pre-construction as an installed air barrier ready for pre-test. But while during scheduling, we found that our air barrier actually needed to look like this with all the windows, flashings, and other transitions, terminations, and penetrations fully detailed in order to do that pre-test. And we had planned for that in the schedule. However, when the flashings were delayed because of a material shortage, the air barrier started to look like the picture on the right with unfinished laps, and our carefully planned sequence dance around the scaffolding and crane schedules with multiple installers just got a little tripped up. And these are pictures of our upper floor access point from a scaffolding scare tower. Access and egress are safety requirements in commercial construction, and as noted before, they take precedence over all else. Before the stair tower went in, there was no way to reach this area of the wall. And since it's at a floor line, there was not a safe way to pre-strip the area, especially with flashing needing to be integrated all at the same place. So this was an area of the air barrier that we knew would be incomplete at the time of our pretest. But if that was really the only thing that we had incomplete at that timing, we would have been okay. And like you can see here, we have a missing flashing saddle that caused this lap to be open and unfinished at the time of our pretest. And that's right at that transfer slab. And speaking of the transfer slab, if you recall the passive house boundary diagrams I showed earlier, this is the bottom of our passive house enclosure at the top of the clinic space. We had several different transitions at this level 4 slab. As you can see here, overhangs, soft courtyards, etc. And with each of these transitions, there are multiple installers to manage from metal framing to insulators, roofers, waterproofers, and siders. From the inside of the clinic, there were also over 100 penetrations in the level 4 slab to get utilities between the residential and clinic floors. Each one had to be sealed and the details verified with material manufacturers as compatible. And we planned a pretest to review the installed air barrier prior to siting. And we did this at Orchards projects with a lot of success. We were able to use infrared and smoke to identify any breaches in the air barrier and then prioritize the correction at those. But at Hobson Place, we had a few challenges. The elevator shaft walls were accidentally unloaded from the train in Chicago, so only some of them made it to the site on time. Mechanical running into some of the shafts were delayed, which caused a delay for the drywallers doing the shaft walls. And this resulted in some very large isolations, as you can see here. On the left is our elevator shaft. And then on the right, you can see our project engineer attempting to keep an isolation in place as we turn the fans on. So for the pretest, we actually ended up isolating the passive house floors a little differently than along the passive house boundary we looked at earlier. And since the elevator shaft was open, we instead tested each floor individually. And the lessons learned from our pretest were definitely not what we expected, but not all for naught. First thing, kind of obvious, we learned to build better isolation walls. This is the designed opening between the north and the south phase buildings, and plywood with tape seam and spray foam edges works so much better than just plastic. We also learned in our pretest to trust ourselves. Even though we were not able to see the leaks with infrared due to scaffolding and warm summer temperatures, we could use our own eyes and hands to identify those leaks and the unfinished detailing. Our site team was all hands on deck during the test or the pretest, with people stationed throughout the building on the interior and exterior scaffolding, reviewing the air barrier while fans were running. And we were able to identify the areas that needed improvement and work to prioritize those in the schedule so that our siding work could continue and we wouldn't have any delays. And with that, I'll pass it over to Greta to talk about our certification process.
Wonderful. And Sharon, I'll just have you click the slides and I'll just give you a holler so you don't have to transition that way. So the realities of the certification process for Big Passive is complicated. FIAS actually encompasses FIAS Plus, which has many co-certifications. And this project in particular had other certifications linked to the project's funding. So it was a lot to coordinate. Sharon had some F words that she talked about, and I'm going to talk about probably one of the most notorious B words in the passive house community, which is boundaries. So yes, this includes the physical boundary of the passive house envelope, but it also includes scope and communication, testing, environmental boundaries, and knowledge boundaries. So this first one is scope and communication. This requires that the verifier is involved as early as possible on the project to understand who else is on the project team, what their roles and responsibilities are, and what exactly we will need to verify. As Sharon mentioned, this project had a lot of overlap with other certification programs. So by having meetings with the general contractor and other subs that were associated with the passive house envelope and mechanicals early, we can better determine where there's overlap and how we can share the work and then share those results. Also kind of goes without saying, but could use some reiteration of the importance of establishing structure and lines of communication with the project team. So we were actually hired by the owner's rep, but most often we are communicating and coordinating these inspections with the GC. And we would often reach out to the subcontractors directly to ensure that we had the correct information. So it's learning, that information ahead of time to know who wants and needs what information. Next slide. The next one is the envelope boundaries. So that's, probably the biggest one in terms of the passive house realm. And as Sharon noted, the sequencing of the project was pretty difficult at times, but we found a lot of success in creating efficiencies from the verification side by overlapping inspections. So for instance, I was able to, when one floor was finishing up insulation, I was then able to inspect the next floor below it for air seal. And then oftentimes by the time that I was done with the air seal, I could go back upstairs and look at the corrections that were made, if any, for the insulation. So this just allowed for, more efficiencies in terms of reports, documentation, and time spent on site. For the next slide here, similar to what I got into, on-the-go problem solving just really allows for, less time spent sending reports back and forth, documenting things. Walsh had a rep from their team who was like their, I think, enclosure specialist is what you had called them. And they walked around with us, and oftentimes like an insulation laborer or whoever, to fix things as we went. So again, it could just be maybe another round of walks to see these corrections. And then I was off knowing that these items had been fixed. For the next slide here, also testing the boundaries. So as Sharon noted, the volume of what we were testing was pretty complex, with only 4 of the 7 floors being a part of the passive house envelope, with basically these legs that went down to the parking portion of the building. So we had, we had the ability to tape off some non-threatening areas. So spaces where the passive house envelope abutted conditioned space at the north phase, and then, at the elevator doors and stairwell doors at the medical facility floors. That shows much of the taping that we did, everything from those doors to the north phase, the elevators, elements that, during a pressurization portion of the test would be blown open. We're able to tape those off, and then things like trash chutes that were basically just connecting all of the floors together. For the last, or second to last one here, we did run into some environmental boundaries, specifically the snowstorm that happened at the end of the year. Now, for those in the Seattle area, or outside of the Seattle area, excuse me, we do have mountains, we do get snow, but it's becoming more and more prevalent, and often, over the past few years, with climate change getting worse, we're seeing worse and worse storms that we are not necessarily prepared for. So there were certain things with the ERV that we had to fly a manufacturer's rep out to help us fix, because there's issues with condensation. So those were, a few hiccups, but ultimately the goal of what Passive House is trying to accomplish is, trying to reduce the effects of global warming so that, we can at least be more stable, so that these types of issues can be, in theory, more predictable. And then for the last slide, something that I think this group will really appreciate is the knowledge boundaries. So I'm sure on this call of, however many, 107 people on here, that there's a huge wealth of knowledge. But sometimes, you're so focused on your particular portion of the job that you're not necessarily thinking about what else you might need to know. So on the left, I'm not an electrician. I don't claim to be, but we needed to measure the power draw for these ERVs to be included within the overall WFI model. So working together with folks who are, experts of their trade and being willing to share that information and knowledge. I often think of the theory of the curse of knowledge, where you repeat your job and your tasks and your technical knowledge so much that it becomes second nature, but to someone else, it's completely outside of, their understanding of the world. So just being willing to share that. And I think that's, why Passive House Accelerator has been so wonderful, because it's able to get folks into the Passive House community at so many different levels, and can meet you where you're at and bring you in and get you to be the nerd that you desire to be. So
Thanks.
back to you.
Thanks. And the slide you've all been waiting for are results. So we completed this project on time and under budget. We were able to deliver 92 affordable homes for DESC, a behavioral health clinic space for DESC in Harborview, which is one of our largest hospitals here in Seattle. We are currently seeking FIAS certification. That Greta's handling all of our paperwork. And our whole building air infiltration rate, and this is for the whole building, non-passive house spaces included, was 0.096 CFM per square foot at 75 PA. And then for the passive house spaces, just those residential floors 4 through 7, our air infiltration rate was 0.074. So under what we needed, yay, with all those complexities. And then our average unit compartmentalization rate was 0.1441, which is well below the requirement. And I'll just take a second to brag. With an enclosure area of over 57,000 square feet, Hobson Place is likely the largest building in Seattle, and certainly the largest affordable housing building in Seattle to seek FIAS certification. So go team, go. Our lessons learned are early planning really pays. Sequencing is great, and all the planning upfront is very well worth it, but also be flexible, make sure you have an ability to adjust what you think is going to happen. It will change. And then trust but verify. We needed to trust ourselves a little bit more, and we had the knowledge and the expertise in-house that we were able to accomplish this, and we really proved it to ourselves. Test early and test often. That definitely helps understand where you can improve things. And from the very beginning, establish a collaborative team from your design team and your contractor and down to every last installer. Everybody needs to understand the goals of the project and be on board to accomplishing them. It's much easier to move forward in a collaborative way, and when everyone's on the same page. And I want to say thank you for allowing us the opportunity to present, and I'll be here for a little bit to answer questions, and Greta, I believe, will also. So thank you.
Wow. Well, I know there's going to be some questions pouring in here. I got a few, and you brought your A team of to get friends to answer these questions. So some of these questions have been answered, but we'll get some good dialogue. But first, take a moment, relax, have a sip of water or whatever you're drinking. We're going to go to Zach.
Oh man, that was amazing. Thanks so much. So I also want to thank the organizations that helped make the accelerator possible and Passive House Accelerator Live happen. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel Foam Glass Gravel, Minitaire All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwool North America, Stocorp, and Zola Windows. Thank you too to our champion sponsors, Icon Windows and Doors, Proseco, and SIGA. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamalux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you.
Yeah, absolutely. Thank you to those sponsors for being a part of this crazy ride for the last 2 years and seeing value in what we're doing. And and being part of it. So thank you to the sponsors. Okay, as I said, some of these questions have been asked, but I see a few people adding more on, and I know some of these individuals that have asked questions can change their questions on the fly. So we'll start with Jeff. Jeff, over to you.
Hey there, Sean. Great presentation. Thank you, guys. Affordable housing with Passive House is certainly the way to go. So my question is two-part. One, was the phase one project Passive House as well?
No, it was not.
Okay, and the second part of that question is for a general question for everybody. When doing a FIAS certified project that has more than one building, do you know whether the solar needs to be distributed to each building, or can it be on one building and still qualify for FIAS certification?
What's the, for clarifying question for that, what's the type of project? Are you talking multifamily? Are they're both seeking passive house?
Good point. So it's one project for site reasons, two buildings, multifamily, affordable, passive house.
Yeah,
Yes.
as far as I understand it, I worked on a separate single family project that had a massive 100-year-old English oak tree on the south side that would have blocked all of its solar gains for the solar panels. So they created a separate building that was just a garage called their solar barn that had all of their PV solar system on it. So I think that you can separate it. I think it's just one of those things that you often have to talk to FIAS about and would need to denote how that would be split, if it would be connected, how it's metered, kind of get into those details.
Yeah, I think your project is relevant if both of those structures were passive house, but you did not distribute the solar panel to the house that had the big tree in it. You just had to provide enough solar for the combined project size. That's relevant. Is that the case?
Yeah, I think so. I would always, my political answer is always, it depends. So I think it depends on the project.
Well, thanks, Sean, and thanks, Greta. Thanks for letting me ask that question.
Always good stuff, Jeff. And yeah, sometimes the "it depends" card has to come out when we're diving into the details, and we need more info on it. So great one, Greta. We're gonna go to Go Girl, who had a couple of questions. So we'll see which ones need to be proposed at this time.
Yeah, thanks, Sharon and Greta, for your presentation. That was really, really informative. My question, I guess my first question was on EUIs and it got answered in the chat. So I'm going to ask my second question and add on a bit. Could you elaborate on the HVAC systems? And maybe I missed that. And what specific problems did you have with condensation with the ERV? And what were the recommendations provided to you by the manufacturers?
That's something that we're actually still working on. So I guess I'd like to reserve answering that too deeply right now. We're still trying to figure out why that's happening. These products are coming out of Canada, so the weather conditions really shouldn't have led to what we saw. So we think there might be a missing piece or something that didn't get installed quite right. So we're, it's not something that should typically be an issue, we don't think, but I guess I'd like to reserve the right to comment on that maybe later after we figure it out.
Got it. No problem. Thanks.
Fair enough. And maybe Scott, when he gets to his turn, he might chime in because I think he might have had some similar experiences. But hold on, Scott, we'll get there. Let me go back up to the queue. Next is Zoe Kaufman. Where is Zoe? All right, well, let me go up to those questions. Actually, while I'm looking for those questions, because I got a couple of things going on, I think Peter just hopped on a phone call, so he's got to wait. And we'll go to Scott. Scott, go ahead and ask your questions and chime in on the.
Okay, well, I actually missed that because I was busy doing a payment certificate for a passive house. But At any rate, my questions were about cooling. Is there any cooling in this building and how is it being done?
No cooling.
No cooling. And did you have an overheating analysis done, and is it going to be a concern?
Well, the building has just started being occupied, so we don't know.
Okay. That was one. And then half a second, I always write them down somewhere. So, oh yeah, I was curious as to how you executed the suite to suite airtightness. That's one we always struggle with. How do you get that suite to suite? Are you using airtight drywall? What are you doing?
Yeah, the basic air barrier for the unit to unit compartmentalization is the drywall. And we're just sealing at the top and the bottom, which is part of I know you guys are all geeks, so ASTM C919 in the
Whatever, I don't
specification
care.
says
Yeah.
to seal the top and the bottom. And when we go through our bids, we just make sure that our drywallers have not excluded that. And then for this project in particular, we actually did kind of a pre-run on unit to unit compartmentalization on the north phase. We have our own blower door. So we tested a few units on the north phase, and we had a huge list of compartmentalization measures. And we went through and did probably, well, what we took the list and we said, which ones of these are typical construction that aren't any kind of cost adds or scope adds. We did that, we tested the units, and then we looked at what made common sense to do in addition. We did those, we tested those. And so we found with just the 80% of whatever was typical construction, along with the few added common sense ones, we were well under the number that we needed to be. So that was actually a cost savings we were able to implement on the actual passive house project. So sealing at the top and the bottom, any kind of penetrations that came through the walls, plumbing penetrations. We had putty packs on the back of electrical boxes. And if you've ever installed a putty pack, you know that it doesn't actually, and there's no way to like stick it to the drywall unless the other side of the wall is open, right? So we don't have little mice installers. So we put the putty pack on, and then the drywall goes on, and then we actually seal around that annular space around the box and the drywall. So that was one thing that was added. We also found, and this is kind of a unique thing to some of our installers in Seattle, the rated boxes that they use eliminate the need for putty packs for fire rating. And so, but the rated boxes aren't airtight. So we actually had to look at that and go back to putty packs in that thing. So that's how we did it.
When you say the rated boxes, they're the plastic boxes that have the gasketing on them?
Some of
Or
them,
are
these
Yeah.
were really, they looked like they were pretty well molded, but they didn't have a gasket on them though.
Okay, yeah, I'm having exactly this discussion in Vancouver right now on the rated boxes. And they come up with a ULC 2-hour rating. And our building code says you can't use a plastic box in a party wall. And these are plastic. And so now I don't quite know where we're going to land. So that's why I asked that question.
Yeah.
The other one is, it's the hollow floors that I find so difficult to seal. Do you caulk, do you block? As the joists go across the party walls, do you block that, or how do you deal with that? Or are you just relying on the ceiling drywall to be airtight as well?
We were relying on the ceiling drywall.
Okay, so you actually, any penetrations in the ceiling, you're also caulking and making airtight?
Yeah, and so in affordable housing, we really don't have a lot of ceiling penetrations. There's not, the lighting is typically, so in these units, like think of a hotel room, it's like, probably 400 square feet. And there's a light in the kitchen area that's usually like a fluorescent kind of thing that goes underneath of a cabinet. The bathrooms do have a light fixture, but in the area where the studio kind of bed main area would be, there's no box or anything in the ceiling. So we don't have that. We don't have too many penetrations in the ceiling.
Okay. And then I guess the other one I was interested in is I noticed your roof was a white color. Is that TPO, or what kind of product are you using up there? And did it influence the energy model in any way, or heat island effect, that kind of question?
I'm not sure on that one. TPO white, yeah. That's a whole nother presentation.
Okay.
It
So I mean,
wasn't, it wasn't something that Passive House had made any kind of determination on.
Yeah. So I mean, the problems you've presented are exactly the same ones we're facing routinely here, and they're just not easy problems to solve. And we are actually not doing. We did one interim air tightness test. The problem was the party walls are so leaky, even though they were fully taped and sealed, just where they hit the outside wall, they hadn't got it right. So we really couldn't do an air tightness test. And we've been saying it's really hard to do an interim. We're just going to rely on our ability to police the work. And we also make sure the trades are educated by the Passive House, either Passive House Canada or BCIT. We find that's just really, really important. Otherwise, we just can't get there. So, but I see you guys had an exterior air barrier. So we're doing an interior air barrier, but a service cavity wall. So a 2x8 Intello, and then a 2x3 service cavity wall is kind of how we're doing a couple of our buildings right now. Interior air barrier. So we'll see how that goes. We'll know in 2 or 3 months.
Well,
Thanks.
Scott, just means you get to come back for a presentation and tell us your secrets and pass it on, because again, it's great that we're working through this. Zach, over to you. Wow, where did we go? Oh, Zach, you muted.
Oops, time flies. And I was muted, sorry. So on the Passive House podcast, we have a conversation between Matthew Cutler-Welsh and Toby Tilsley, who is a builder with Craft Homes. He talks about his journey to Passive House, of course. And it's a really, it actually was a very powerful episode for me. It reminded me of my dad and all sorts of stuff. Anyway, great conversation. Check it out. I just put in chat a bunch of registration links because we have a ton of events happening in the next 2 weeks. So on Tuesday, March 22nd, we have another Passive House Accelerator Summit. This is Passive Prefab. It's being organized by Mary James. Prefab from design to delivery, with a very distinguished panel of guests speaking. So please join us on the 22nd. Then next Wednesday for Passive House Accelerator Live, we have the Construction Tech Edition, and we are joined by 2 experts from Stephen Winter Associates, who are going to be talking about field adventures with heat pumps and ERVs, Carla Butterfield and Scott Pusey. So we'll see you next Wednesday for that. Then on Thursday, 9 a.m. Eastern, 6 a.m. Pacific, 2 p.m. GMT. Actually, those times might be wrong because of daylight savings time. So it's 2 p.m. GMT. I'm not sure what that means for us in the US and Canada. Anyway, we have episode 6 of the Building Performance Interactive, Achieving Thermal Performance in Modular CLT Developments. You can find a link in chat for that. And finally, we have, is it finally? Uh-oh, oh shoot. No, not finally. We have Lloyd on talking about living the 1.5 degree lifestyle, with a couple of special guests joining him for a panel discussion afterward. That's on March 29th at 4 p.m. Pacific, 7 p.m. Eastern. And now finally, my last one is we have Rockwell North America joining us for a Passive House Component Spotlight on Thursday, March 31st, Durable and Resilient Retrofits, Solving with Stone Wool Insulation. Find all the links in the chat. Thanks, everybody. Off to you, Bev.
Wow, well, you're going to be busy, Zach. Well, I just want to say congratulations to Passive House Accelerator on 2 years. What an achievement. Thank you to all the organizers, to all the speakers, to all the sponsors, to all the newbies, to all the regulars. Like, congratulations and thanks for joining.
Thanks, Bev. All right, everybody. Well, that concludes the first hour. We're going to go to the overtime where we're going to dive into more of the questions, and we'll see how long, again, Greta and Sharon will join us. I have a little bit of a selfish plug as well. For those that know that we've talked about this experience, Passive House experience, we've come about where I created a fart shack for my dad. It's a Passive House art shack. where it's a mock-up for Beat Collective. And today is like 2-for-1 voting. So if you can vote for me, there's a good chance that I might win this thing and help be able to take some funds and help promote and work with the Pass House community to keep going. So if you don't mind, just going to throw it in there. Because it's been a fun project with my dad. And I don't know how Mark got me involved with this. Somehow I applied and now I'm accepted, and hopefully we can get Passive House into a very interesting market. So little shameless plug. All right, back to the questions, everybody. Zoe is back and you can kick it off. And again, Sharon and Greta, you let me know how long you can stay in the after hour. So Zoe, over to you.
Well, thank you, Sharon and Greta. That was kind of a info-packed presentation. It was really great. So thank you. I am amazed that you got through it. My question was about the ERV measurements. You even showed that picture of measuring the power draw from the ERV. What did it come out to? Was it what you expected? How did you get it to a point that you were happy with? Because that's been kind of a big concern with multifamily passive house with big centralized ERVs, is that it's hard to plan for those and know what energy draw you're gonna, or power draw you're gonna have. So
yeah, great question. So to be honest, I don't have those numbers in front of me. I'm at a slightly different computer space. But the few issues that we did run into with getting it balanced, we were able to, and with the snowstorm and whatnot, we were able to get it back to where we needed it to be at a point where it was servicing, supply and exhaust, based on a lot of the documentation that the HVAC contractor that was testing it had documented. So they were able to document, multiple different system setups and completely, like the static pressure, which is like a huge telling point for a system like that. So I would say ultimately just, know how to document those things. I know that there's a lot of like fan curves and stuff that you can refer to now. So looking at a system that you're not going to, it's not going to be oversized and that it's not going to reach its maximum efficiency, but just kind of finding that like just right in between system. Are you approaching this question from like design side, from what kind of side of the project, Zoe?
I'm approaching it from maybe a similar lens as you are, as a previous passive house consultant and verifier. So this was kind of, so it was tough to plan for me because most mechanical engineers wouldn't necessarily take account for all of the pressure, I guess static pressure loss, if I'm, is that what
having
we're
too much,
about?
Too much pressure.
Yeah. So
it definitely does take like, having a really great design team in terms of laying out the ductwork. Something that I learned over the years as a verifier is, truly all of the iterations of mechanical spaces. And Sharon had a great photo of, this massive amount of ducting that was like built up into the hallway. And then, I would just say like, truly don't try to shove mechanical systems just into a closet. Like they need, especially for these commercial projects, they need to have considerable space to be able to run properly. And to really have a great design that will, not have a crazy amount of 90-degree angles if possible, and trunk sizes that are able to have the capacity needed to service these, mini units, especially for these large ERVs and HRVs.
Okay, thanks. Yeah, I'm glad that it wasn't a major issue for you once you're testing it. That's good news.
Great, thanks. I'm glad you got questions, Enzo. Mike, let me just see, Mike's still here. Mike Caskey. I don't see that Mike is still here, so we'll move along to Jason. And don't see Jason, so we'll keep going here. Over to Melvin.
Hi, can you hear me?
Yeah, we're good. There you go.
All right, I'm on the move, so I'm trying to remember what my questions are. I think
Modular construction.
Yeah, the commercial portion. What was the reason for not including that in the passive house? And taking the lessons learned from air sealing that during the blower door test, would you consider the commercial portion for passive house next time?
So it really wasn't our choice, I guess, is the answer to both of those. But this design for this building in the program of the residential over top of the clinic space, all of that was determined prior to the team committing to passive house. And so the funding for passive house, the passive house measures that were added were per unit and were not, they weren't allocated to the commercial space. There would have been probably too much on the design side to have gone back to make the design moves to make the lower floors also passive house. We had a lot of storefront in that, and the team had already gone through their design review planning and all the planning with the city. So it was really just that it was, the funding was for the residential spaces, and that there wasn't time to go back in the design and do that. Would it have been easier to do a building that was all absolutely for passive house? And we were so close in terms of the air tightness. So we probably could have made it work with some minor moves, but obviously that's hindsight. And was there another part of your question that I missed there?
I think that answers the commercial portion. I had two other questions. Why not do modular construction? Because in Vancouver, it seems like for the at-risk population, the modular construction is quite popular.
Why not do modular?
Yeah.
For this project, it wasn't something that was considered. And we have Walsh Construction, maybe Mike can help me out here a little bit, Mike Steffen. We have done some modular. In a lot of cases, we find that stick framing, whether it's, well, I guess it is somewhat modular because like this project was panelized. So there were panels that are at least, semi truck size that can fit, that are delivered to the site and erected in that manner. But either still or panelized framing tends to come in less expensive and meeting schedules just fine. So that's kind of where we are in the market. We have found some opportunities to do modular where it does make sense. And those are just, project specific, I'd say.
All right, and one more question. I noticed that these walls had like a single layer instead of a double layer wall system, and there was a lot of structural wood framing. Was there any concerns with dew point or condensation or any cold spots?
Yeah, that's kind of one thing that I talked about it in the presentation. I know I went through super fast, but we used a 2x8 wall with R30, R31 insulation, and that is just kind of the sweet spot. And I think it's probably only really for our climate in the Pacific Northwest where you don't get into condensation problems quite yet. If you were to go to a 2x10 wall, you would see that risk increase. But that 2x8 wall with the R30 insulation works okay for Pacific Northwest. Now, going forward, our codes are going to be requiring a little bit more insulative values in the walls. And so we may see this as kind of a just a time period that option even works before we have to go to exterior insulation. So no, we didn't have any condensation problems. Yeah, I mean, we insulate our slab edges, which is probably where the biggest risk in this building type is at, and those are fully insulated.
Okay, great, thanks.
Great questions there, Melvin. Yeah, just to clarify too, in the City of Vancouver, in the affordable where we use modular, the modules are not to passive yet. We have bugged them. So hopefully the next phase of it will be more high performing. But again, it's great that we took care of the affordability issue, but they definitely were criticized for not doing high performance. And you know who was doing the criticizing? Might be this guy.
Sean and everybody, I have to take off now, but I appreciate all of your time and attention for the last over an hour of listening to me talk very fast and pack in a bunch of information. If anybody has any questions, my email was there at the end of the slideshow.
No, great stuff. And before you go, why don't we everyone unmute and give both of you a cheers, a clap, whatever you need to do to just say amazing work. The presentation is fantastic. And again, great to see the other part of your team there supporting you along. Again, Walsh is, again, it was great to see their Portland project, but great to see another one in, again, in the Pacific Northwest. You guys are just hitting things out of the ballpark with these projects. So it's great. So that being said too, Greta, what's your time? I actually have to leave in a minute as well. So what's
I'm here.
You're able to, okay, well, and again, I see Mike, so maybe Mike can jump in for Sharon. And again, if Mike doesn't want to, I know Zach will give him a bit of an elbow to stick around. So I'll let them two sort it out. I have to jump off as well. I'm going to head out for birthday dinner. But I, again, just want to say thank you to everybody for showing up every week. It is a pleasure. Honestly, Wednesdays are the best days of the week. Used to be Tuesdays and Wednesdays, but now we just solidified it into Wednesdays. And so can't thank Michael and Zach enough for continuing to allow us to do this every week. Thank you to all the presenters that show up and the sponsors and the full team at the Accelerator, Mary and everyone else. I know Shannon and Mark are somewhere in this grid. Thank you all. Have a good night. And I might be hanging out with Donald Duck and Mickey Mouse next week. So I'm going to take a week off if that's okay. And I'll see you in a few weeks. But I will try to pop on to the prefab show and to the next week's, but maybe it might be in a lineup at Disneyland. We'll see. Maybe it'll be from Splash Mountain. So good night, everyone. Zach.
Happy birthday, Sean. Thanks.
You.
Yeah,
over to you.
Well, all right, great. So thanks, Melvin, for that question. I think Jason, when you had one and it seemed like you're on the call. So I'm going to give you one more shot at coming on and asking a question.
Oh, hey, sorry.
Hey, great.
Yeah,
great. Hey, Jason.
I'm tuned in now. Just wondering how the CertainTeed membrane was to work with as the interior vapor control layer. I've heard it seems to be about a third the thickness of regular poly. So I've heard complaints about its fragility.
Greta, I imagine that this is a question for Mike, you think, or do you have?
I mean, I can speak to it in terms of when I would go out to do the insulation inspection, oftentimes the membrane was on there and I'm, physically pressing to feel the compression of each of those stud bays, and it was just fine. But yeah, if Mike, you want to speak to that more.
Mike, are you available?
Yeah, it's not as robust, let's say, as 6 mil poly, but 6 mil poly has a bad rep.
Yeah, that too.
In our part of the world, so nobody uses that. So it can be damaged by other trades and such. The thing is, it's important to remember it's functioning as the vapor retarder or the vapor control layer, and a tear in the material doesn't diminish its ability to serve its function as long as it's covering the surface area. So it's not like an air barrier where if you get a hole in the air barrier, now you've got a little pinhole even where a lot of air could leak because of pressurization. Vapor diffusion works as a factor of surface area. So you get a rip in the CertainTeed membrane, it's not a problem. And actually, it's worth mentioning that Sharon kind of alluded to this a little bit, the vapor or the moisture profile, the vapor drive and moisture design profile of the 2x8 wall with the R30 insulation in our climate in a wood wall works quite well. It shows a little bit of moisture risk, but that is actually the reason that the design teams here specify the membrane product, because it provides a little tolerance for that moisture development. And then the fact that the wall can still not breathe, the word isn't breathe, but it can dry to both the inside and the outside. So that's actually a reason we use that material out here. If you got into a colder climate, then your condensation risks might be much higher with that wall design, but it works well out here in the Northwest, west of the mountains.
Great, thanks.
Fantastic. Thanks, Jason. Thanks, Mike. It looks like Peter from Small Planet Supply has signed off. So the next person up is Shannon. Shannon, are you available to ask your question?
Yeah. Hi, Zach. Can you hear me?
Yes, sounds great.
Awesome. Happy 2nd anniversary over there. And I wish Sean a happy birthday, but he's already off. And Greta, great job. I just can't imagine the complexity during COVID, supply chain issues, a lot of overlapping insisting things happening on this project. I was really, really impressed. So my question, the first one really had to do with trying to prove the return on investment for the client. Was solar designed in the early phase and used to project an ROI?
I can't speak to if it was included in pre-design and what that portion looked like. This might be a better question for Mike, but there's a ton of solar on the roof. Basically, most of the roof's square footage that wasn't being used for the mechanical systems, like the ERVs and whatnot, was dedicated to PV system.
Awesome, thank you. And the second question should be up your alley. Was there a penetration schedule used or recommended? Do you guys recommend that when you're on early in a project?
It's not necessarily something that I would say we recommend, but we've made it very clear to the projects that we work on that we need to, see all of the air seal prior to cover. We kind of leave the element of penetration to the general contractor and how they want to, deal with that with their subcontractors. But we definitely make it a point to be out there for every time air seal is completed before there's insulation installed.
Yeah, great job managing that. Thank you.
It's a great question, Shannon. I think if you had a GC involved in a project that wasn't proactive on the quality control side, it would be really important to do something like that, because I think that's one of the values that we bring to the project, is that kind of proactive approach to manage those things and be thinking through them ahead of time, even at the estimating phase of the project. So it's not a surprise to the client downstream from a cost standpoint, but certainly in execution, you need somebody, and it is the GC's job basically to manage that. So if you have a less experienced GC or one that's either resistant or hasn't been involved in passive house before, I would highly recommend the design team develop something like that that's pretty detailed. It was interesting on the Orchards project, the biggest air leak we had on the project was a penetration, and it was a penetration nobody thought about. It was where the electrical conduit came in through the bottom of the building from the street vault at the and it was it was a 4-inch conduit with all this wiring coming through it, and it came up into the electrical room on the ground floor of the building. And who would have thought of that? None of us thought of it. But when we ran the test, I mean, that's where, probably 10% of the air leakage of the project was actually happening through that 4-inch pipe that had bundled electrical cable in it. And I'm trying to remember how we even discovered it. I can't quite remember it. But then we did, it was a matter of doing some remedial air sealing with spray foam around all those wires to kind of cut that leakage down. But that's the kind of thing that experienced teams can bring to the table and scope out, I guess, for less experienced people on the building side.
Yeah, and thank you for sharing that, because now everyone here can benefit from that one. Appreciate it. Great job.
Great. Thank you, Shannon. Thanks, Mike and Greta. So our last question comes from Peter Molinar. And I see you, Peter, so I know you're ready.
Yeah, for Greta, did you specify LED lighting throughout for energy efficiency, or what was the given lighting regimen?
So even though we're included, early on in the project, we don't necessarily specify anything. We just tell the project team what is required by FIAS and then the co-certifications. And majority of the co-certifications now require LED lighting. So that was included throughout. Many of the stairwells also had, motion sensor lighting. So really trying to make sure that the spaces were lit, but not lit when they didn't need to be.
Yeah, that's good. Well, I was site supervisor for LED lighting projects for 3 years, so I'm familiar with all that. And the stairwell motion sensors were a very good idea because they're not needed mostly, but when they are, well, their lights are on. But good to see the LED lighting come in. That's very good. Thank you.
Great. Thank you, Peter. Well, I think that wraps it up. So what an incredible project, Greta and Mike, and thank you to both of you and to Sharon for this amazing night. And I would second Julie Blazek's proud Washington, because I feel like I can ride in on your coattails and feel proud of this project because it's in my hometown. And it's just super exciting to see projects like this happen in Seattle. So thank you for sharing it with everybody on the Accelerator. Thanks everybody for being here tonight, and we'll see you next week. We've got a lot of stuff going on the next couple of weeks, so hope to see you at a bunch of things.